Sophie Germain was a French mathematician and physicist who had to overcome the prejudices of her time in order to gain recognition for her talents. Born on April 1st, 1776 in Paris, her family was quite wealthy, with her father being a merchant and then director to the Bank of France. She began showing interest in mathematics at the age of 13 after being cooped up inside due to the French Revolution. She taught herself math using her father's library, and even learned Latin and Greek in order to understand the works of Isaac Newton and Leonard Euler better. However, she was discouraged by her parents, who believed that a girl of her status should not be learning such subjects, but eventually they relented to allow her to pursue her passions. In 1794, when Sophie was 18, the École Polytechnique was funded, but women weren't allowed to enroll. However, she managed to obtain lecture notes and study from them, giving her the chance to learn from prominent mathematicians of the decade. She was particularly interested in the works of J.L. Lagrange. Under the pseudonym M. Leblanc, who was a former student of Lagrange, she began writing and submitted an analysis at the end of the term. After meeting her and discovering she was a woman, Lagrange acknowledged her talents and skills and became her mentor. Yet despite being taught by a notable figure in math at the time, her gender and even social status were a hindrance to her talent. In 1804, Sophie began correspondence with Carl Friedrich Gauss, a German mathematician. After becoming fascinated with his work in number theory, she sent him some of her own work using the pseudonym yet again. In 1808, she wrote Gauss a letter telling him about her work in number theory, just to never hear back from him as he had stopped his work in number theory and began teaching at the University of Göttingen. However, 12 years later, in 1820, she accomplished her greatest achievement within number theory. Germain's theorem proved that if x, y, and z are integers, and x to the fifth plus y to the fifth is equal to z to the fifth, then either x, y, or z must be divisible by 5. Germain's theorem was a major advancement to proving Fermat's last theorem. It stated that if x, y, z, and n are integers, then x to the n plus y to the n is equal to z to the n. It cannot be solved for any value of n greater than 2. During her investigations into Fermat's last theorem, she used prime numbers of the form 2p plus 1, where p is also a prime. Prime numbers like p are known as Sophie Germain primes, and the corresponding numbers 2p plus 1 are known as safe primes. 11 is a Sophie Germain prime, and 2 times 11 plus 1, or 23, is its associated prime. It has been conjectured that there are infinitely many Sophie Germain primes, but it has never been proven. Sophie Germain also worked in theoretical physics. Her other notable work had to do with the vibration of elastic surfaces. A paper she wrote won an award from the French Academy of Sciences, and her work also played an important role in the theory of elasticity. Sophie Germain died at the age of 55 on June 27, 1831, after battling breast cancer for several years. During that time, Gauss, her former friend, convinced the University of Göttingen to give Sophie an honorary degree, but she passed before she could ever receive it. Sophie Germain was a bright woman whose accomplishments should not be overlooked. She battled against social norms and prejudices of the era and succeeded despite the many obstacles across her life.